Aloha, Richard Halverson here. This is ICS321, and this is spring 2021. It is the second class period of the semester. And let's see, let me share my screen. 3. All right. Okay, so we are in week 2. And I'm noticing that week 2 is really when chapter 2 starts. That's good because I guess I just started chapter 2 the first class period, but I didn't do a very good job on it. So I'm going to kind of almost start from scratch again with this class, and so that will be the link for that video will be right down here in, right next to class 1 as soon as it's done, or later this afternoon. And then and then we continue on the zyBooks chapter 2 next week, which is good because I think this zyBooks chapter 2 is actually a pretty good chapter. I should be able to contrast it with what's going on in Dates chapter 3 there. So so let's take a look at the textbook. Okay, so the last let's see, the last class period I ended right about here. I ended let's see, I ended with is this thing going with challenge activity 2.1.1, which is at the end of section 2.1. So let's go back to section 2.1. And I'd like to just quickly go now. Okay, so now I've gone through this now, and I can see this is actually pretty good. One really good thing about zyBooks is they spend a lot of time talking about what happens when you have null data. And null data is a fact of life in MySQL. And the trouble with the date book is, and a lot of other texts and teachers and so on, is they just say, well, don't use null, don't ever have null, and then take care of unknown data more by interpretation than the fact that something might not be there. But anyway, so that's good. But okay, so chapter 2 starts talking about the relational model, and that's only one model for databases. The relational model actually was invented by this guy named E.F. Codd back in 1970s. In fact, there's a reference to his paper down here, right down here. But you have to pay to see it. But anyway, so this chapter gives some history of databases, and you may have heard of NoSQL and MongoDB. We aren't going to talk too much about that in this class, but you're starting to see those in other classes, and especially big data. But so this is a historical question. It talks about the relational model, and these terms, domain, tuple, and relation, are the terms for when we speak of relational data in relational algebra and so on. And but these have similar corresponding terms when we talk about databases like SQL databases like MySQL or Oracle, or if we talk about just files. Files are a form of a database table and so on. So but these relation and table and attribute and column and field, these are all important. Record, row, and tuple. These are all important concepts which which will be used interchangeably. So the sooner you realize that these are just all terms for the same thing, and it says more about the context of what you're, the topic of the reason, you may call it a tuple at some time, you may call it a row some other time, and it's usually the context or the point that you're trying to make. So anyway, that's all these here. And the thing about tuples in relational databases is the order doesn't matter. Okay, the order 7, 2 is the same as 2, 7, whereas I guess in mathematics it's not. So you have this relation is the same as this relation because the tuples themselves are the same and the order doesn't matter. The big thing about relational databases is, you have tables and you have columns. You can think of them that way. And the order of any of that, of any of those doesn't matter. The order of the columns doesn't matter. It's just like the order of the attributes, the order of the values inside of a tuple don't matter. If you got a bunch of tuples, the order that you have them in don't matter. And all the operations that you do, the result should always be the same, no matter what the order of any of those things is. Okay, so that's kind of an important point to remember with all this. So this is, see, we're still in section 2.1. Here we are still in section 2.1. Okay, the concept of rules is kind of an important concept to differentiate between these kinds of rules in zyBooks, and it's similar to other ways of presenting this, relational database theory, but they've come up with some good terms here for these, and so I think we should use these. There's relational rules. So there's rules with these tables. You have these tables that have data in them, and these tables have columns and column names, and they've got rows, and there are structural rules and business rules, and a structural rule is things like it has to have each row has to have each table has to have at least one column that is defined where every value in that row is unique. Okay, and so that's the key. And so an example is like if you have a database of students, their their 8-digit UHID would be like a key. And so you have this table that's got all UH students, and so that can be a key. It turns out that your username, your UH email address, username is also a good primary key for tables of students here at UH. But also there's columns, and the column names have to be unique. You can't have two columns with the same name, and you're not supposed to have duplicate rows either. Okay, so now you can still have tables in a MySQL database that violate these rules. Okay, especially no duplicate rows. You can have duplicate rows as long as you don't have a primary key defined. Okay, well, once you have a primary key defined, then you are telling the database that you want to enforce this rule that no two records can have the same primary key, and then it'll reject it or something. it won't let you create a primary key, or it won't let you specify a column as a primary key if, when it tries to do it, it finds that there's two rows that have the same value. It'll just say, sorry, I can't create this column is not a valid primary key. Okay, so there's structural rules, and then there are business rules, which also can be enforced by MySQL, by the actual database. And they're called business rules because sometimes you have them and sometimes you don't. There are attributes or rules that you can select to enforce or not enforce when you're creating the table, and it still follows structural rules. For it to be a relational database, it has to follow the structural rules. It doesn't have to follow the business rules. Okay, so one is that you can define a column as being unique. Now, a column that's being used as the primary key, that has to be unique. But you can define other columns as having to be unique, and it's just something that the database enforces, and it doesn't allow, it doesn't allow you to violate that rule. It will reject an insertion, or it'll reject an update if it violates that rules, if you choose that column to be unique. And an example would be a table of students where your UH email address or username is let's see, I gotta make sure. Okay, every now and then I gotta make sure I'm actually recording, because every now and then I'll forget to start the recorder, and then I've done a whole thing with the only people that benefit are you folks that are here, and there are a few of you here, which is great. All right, so with these business rules, you can define columns as unique, where every time you put in a new row, the value in that column has got to be different than every other row. It can have no missing values. In other words, they can't be null. So you can say that it can't be null, or it can be null, and it when a row this delete cascade thing, where if you have that's only relevant if you have foreign keys. So if you have if you have an employee that is part of a department, if you have a database and a table of employees, and in that table, or in the table of employees, there's a field which indicates the department, okay, and it indicates it as a foreign key into the table that defines the departments, then you cannot, then there's a relationship between those two tables. And so if you try to delete a department, and there's still an employee that's in the employee table that's linked up to that department, if you have delete cascade, deleting the department will delete any of the employees also. Okay, so you can set it up so it does delete cascade, in which case you do that, or you set it up where you don't allow deletions of a department if there's still an employee that's a member of that department. So that kind of thing. So you have to think about, and further on, it asks you, is it a structural rule or a business rule? And you can you have to kind of think of it in those terms. Okay. So here in this participation activity, it does this example where you have Sam, you have some employee named Sam Sneed, and you have another table of tasks, and this table of tasks has got tasks assigned to Sam Sneed by virtue of this 5384. That's Sam's ID number, 5384. So if you delete Sam, then you're going to have to delete these tasks too, because otherwise these tasks will be there and they're in there, but they're not connected to anybody because there's this it's an orphan, uh, you know. So you want to so cascading will automatically delete. Yes, when the employee is deleted, the tasks are deleted also. All right, so here we're asking a primary key is an example of a structural rule or a, let's see, where am I? It's 2.1, and I want to get through all the way to section 2.4, I think, today. Let's see, today I want to cover 2.1. Oh, I want to cover up to 2.5. Okay, so I better speed this up. I'm only going to include the important stuff, or I'm only going to point out, I'm going to assume that you go through this pretty carefully. Okay. Okay, yeah, this is where I left off, and here we're talking. The first one is the point is that the order doesn't matter, and I can't remember the second one or the third one. But anyway, let's move on. Okay, so that's pretty much where the last video ended. Okay, with that last challenge activity. All right, so now we're into new stuff. If you haven't seen this already, and tables, columns, and rows, and we're defining these things. A table is the whole thing that has columns and rows, and the column is, you can think of a spreadsheet, and it's got where the attributes are across the top. The fields are across the top. They're named, like date of birth, first name, last name, address, so on. Those are the columns. And then there's rows, and a row would be like one person or one record. One tuple, that's a row, and a cell is the intersection of column and a row. It's a value. It's a single value. So we're columns and rows. Names for columns and rows, pretty obvious. Okay, these are a cell holds a value, and these are all the different kinds of values here that are kind of built into every database. Okay, and they're enforced. It's not like lazy programming languages. Well, Python's not that lazy, but other programming languages are lazy. You just anyway. So integers, decimal numbers with a decimal point, and digits both sides of the decimal point. There's character data types. There's like char and varchar and text, and they can have different sizes. And if you define a varchar or a char as being 10 characters, then a char of 10 characters is 10 characters. A varchar of 10 characters is up to 10 characters. If you try to put 11 characters, it hacks it off. So it's much more rigid than programming languages. And then time for representing the time, and then there are these other kinds also. All right, so okay, tables are normalized. No duplicate column names, and no duplicate rows. Okay, so it's kind of like we're saying that a MySQL database can have a table that's not really a table, because you can create a MySQL database that's got duplicate rows. So you can have a MySQL database that's got duplicate rows, and you can do select statements on them, and get in and so on. And that's because it doesn't have a primary key defined. And so the other problem I have with this is null. How do you interpret null? Well, I think in zyBooks they may interpret null as being a value, and there's kind of an algebra. And as we go into a couple sections later, there's true, false, and null, and there's having a value and then having a null, and there's the evaluation of expressions when there's null values in there. It's just something. It's just another thing that you have to learn. So anyway, this but data independence is important, and that's where you can have rows in any order and columns in any order, and all the operations don't matter. And this means that their actual physical storage on storage devices can be they can focus on efficiency. And so there's no that this record's got to be next to this record, because when I'm searching and reading them up, I know the fact that they're close together, that it's going to take less time. You can't do any planning like that. All right. So this talks about the rules governing tables. There's some of these rules cannot have multiple values in the same cell. Obviously, rules cannot have multiple columns with the same name. See, like this one does. Let's see what's the matter with this. Table cannot have multiple values. Oh, I see. This is like having two, like Maria here gets two salaries. I was thinking this was a row that had no name and no ID. Cannot have multiple columns with the same name, and also cannot have multiple. And the reason you can't is because one of these has to be a primary key, because I can go over to MySQL right now and create a table that looks just like this, and it's a table, and everything, but there's no primary key defined. So that's why it accepts it. All right, so this reinforces that. Okay, here we start talking about null values, and I've been a database programmer for a long time, and I've always, sort of learned where if you're going to take advantage of null, you're sort of it's like witchcraft or something. But no, this. The other thing is that it seems like it is vendor dependent, and some of these things are vendor dependent, and it's like, if it's one way on MySQL and a different way in Oracle, then I don't think we should be teaching that. I think you should avoid that. It's not necessary. So anyway, this talks about null values, and null really is different than blank, and it's different than zero, and it means you don't know, and it could mean that. Okay, so in this example, we have somebody named Sam Sneed, and the birth date field is null. Well, Sam has a birth date. It's just that we don't know it. So that's null, means we don't know it, we don't have it, whereas we're waiting on Sam to get that to us. But over here, this in the bonus field, null means zero. It means there's no no bonus. You know, if you work in engineering, you don't get bonuses. So that null means, you know, it could mean, you know, we don't uh, have you know, a concept of bonus over here. So anyway, um, so uh, but there's going to be it's kind of, you know, you still want to be able to have nulls in there for both these reasons. Um, you know, you want this to be acceptable. I mean, you really should put 0, I guess. And here you should put something which would indicate a birth date, but an unknown birth date, but you can't really do that because you're also going to enforce that in this field, it's got to be a date. And if it's got to be a date, then it's got to be a date. And so you're either going to, if you don't know it, you know, so anyway, so you get my point. So this here we start, and it talks about a lot what happens when you do have nulls and how you can, you know, be careful. You know, you can they're there, and what's some of the things you have to be careful of when you have nulls in your database. Uh, now, another point I wanted to make is that um, this the date textbook tries to avoid this, and where you're sort of mixing up the operations that go on inside of a row and operating on rows, uh, as opposed to thinking about a table as the actual unit or the variable. And so date, if you know, when you go through date, you learn that he doesn't like, you know, select and update and delete and so on, because it's kind of row focused, and it's not whereas he wants to talk about relational algebra, and the variable is the relation, or it can be it can be a relation with one row and one column, which is kind of what a scalar value would be, but here in this book we talk about, you know, the SQL language has several operators, you know, plus, minus, times, divide. Well, we aren't saying plus by adding two tables together. We aren't saying we're going to subtract one table from another, or we're going to multiply one table to another. You know, so date would not like us to use this, you know, sort of not making that distinction. Is one table greater than another? What does that mean? So anyway, I just wanted to point that out. And I think it's kind of an interesting distinction, but it is kind of academic. So anyway, so here we're talking about null, and this is what happens. This is explaining what happens if you have null values, and you know, you have regular old, you know, where restriction clause, where you want to display up everybody whose salary plus their bonus is greater than 30,000. Well, you can't really write it this way, because what is a salary plus a null? Okay, it's you know, a salary plus 0 is just the salary, but null, you know, what is that? So it turns out that if you have that salary plus a null is going to be null, and then is null greater than 30,000? No, null's not that. So you know, whoever had null for a bonus ends up not being on the list, even if the salary would put that person on the list. You know, so so you have to keep that in mind. You have to test for it. You know, you could first is, you know, well, You know, you have to write this expression differently to take into account that the bonus may be null. Here, birth date equals null. Okay, so it's not equal. It's used this is infix operator here. If birth date is null, so that gets Sam here. Birth date equals null is not. That's not. It's not. Equal does not apply. It either is null or it's not null, but it's not something is equal to null. So anyway, it's an important distinction. Yeah, right. Yeah. Yes. Well, yes. The expression is correct. Well, yes, but the table could very well. Somebody just asked, direct message me. I would think the expression is correct, but the use of null was wrong. Um, yeah, yeah. And I can't offhand write what they meant. If I had MySQL up, I would be able to figure out what it is. But I mean, you can do it, but this here might just be, you know, how it is. I mean, it could be that the person that makes the decision of how null gets put there for engineering rather than zero is, you know, that. So anyway, that's the kind of thing that can it just means that, okay, so the the SQL programmer is going to take care of that problem. Okay, so anyway, I'm sure we'll figure out what uh, uh, what a better way is to write that. But okay, so here in this participation activity, what name is selected by each statement? Well, this one would be um, uh, Jiho, because the salary is null. So the name would be Jiho. And this one is salary equals bonus. That would be Sam. Sam's salary was the same as his bonus. This one would be salary divided by bonus is less than 1. Well, gee, who knows what's going to be there? I would guess that because you've got some sort of operator here where that does not work with null. Division does not work with null. So so that means that anything that's got null for bonus or null for salary is going to be null here. And is null less than 1? I don't know if null is less than 1. I would say that's false, but so I'd say that's false. So I would say that the answer would be salary over bonus is less than 1. This one's equal to 1. This is less than 1. So I'm going to say, I think it's, yeah, so yeah, I agree. I think it's Maria. Ah, good. Since the division and less than operators return null when either operand is null, the result is Lisa are not selected. Oh, they're just because it's false, because you can't, because this operator does not work with null, I guess. All right, so here's okay, so here's some cases where you can use it, where it doesn't cause a problem. And here, so if you want to, if you're using the sum operators, these um, what are they called? Group type operators, then they are kind of protected against having nulls in there. So sum works, even though there's a null in there. So if we're selecting the sum of all the salaries plus the sum of all the bonuses, the bonus sum is going to turn out okay. Okay, so the null will be interpreted as 0. So this ends up being the right answer. But if you do it this way, it doesn't end up being the right answer. Because why? I can't explain it, I guess. Because when it comes to this ends up being null. And then, oh yeah, this ends up being null. So salary never gets added in. That's why. Whereas when you do it this way, that row where the bonus is null, that salary does get added in. So that makes sense. And so here's what truth tables look like. When there's a null, there's like a third value here. And so it's, when you're ANDing, null is kind of treated like false, except for it's called null, because, this is true and false is false, false and true is false, and false and null is false. Okay, well, that's good. It's not null. Null and false is false. So false is still, it's like, false still cancels out a null, I guess. But then we have this here, null and null is null. And for or, it's like true, wins out. Truth wins out. Null wins out. False loses. False always loses. False always loses, and truth always wins. And here, not true wins. Yeah, not true wins. Anyway, all right. So so that's kind of interesting. Okay, here we haven't done this challenge activity yet. So select ISO code 2 from the country from country. This is the table country where area is not null. So or area is not null. So that would be France. Okay, start France. The country ISO 2 code, yeah, FR. Yeah, okay, next. Min population of country. Population, min, this one. Yes. Okay. Oh, area plus 1. Okay, so that would be, I'm going to need a calculator for this. The maximum of area plus, okay, so it's going to be the maximum of this. Because all the rest of these, well, this is going to be 300. This is null, this is null, this is null. So it's going to be, let's see, thank you. 193,000. And then this one is going to be, it's going to be 297. What's 297,000 plus this? It's whatever that is. Great, 413000, okay. 413000. All right. Whoa, pretty good. Okay, fantastic. Okay, so anyway, you can do those. You get the idea. Okay, I said we're going to do primary and foreign keys, and then the next one too. What's the next one? Yeah, referential integrity. Okay, primary keys. A primary key is a column, or it could be more. It could be a group of columns, like 2 columns. That will uniquely, that it can be used to identify a row. And so, like an ID, an employee table below the primary key is ID because everybody's got a unique ID. Every employee is assigned a unique ID. So this is just the way this book chooses to note the ID, that's the primary key. Date underlines it. And it's a good idea if it's not really related to anything. Well, you know, with UH, if we force everybody to have an email address, and I don't know if everybody has to have an email address, but I suspect the 8-digit number is really what the key is, what your key is in the system. It used to be Social Security number. When I started, when I was a student at UH back in 1988, when I first came here, it was my Social Security number. It was that at the University of Minnesota also, where I did my undergraduate stuff. All right, so that's primary key, and it talks about alternate keys or candidate keys, and those are other things that could be keys. And as in the case with UH, you know, your email address, username can be a key, so that can be a candidate key. That uniquely identifies you. In fact, in Laulima, it uniquely identifies you. In my UH, it uses the 8 digits. But anyway, so name is not a good primary key because two people can have the same name. A new employee can be added without an ID value. No, got to have a primary key there. A new value can be added with this. No, that'd be Sam's ID. And no alternate keys are present. I would say no alternate keys are present. All right. Now, composite primary keys just means that it's a pair. It's a pair of columns, and you know, in dates. In dates example, a supplier parts database, of course, the SP table, you know, has the key is the composite. It's the supplier key, SNO and PNO, or the parts key. So that's an example of a composite primary key. And this is a pretty common way, common use of a composite primary key. It's like, you know, family like this, where you just have another key that just, you know, like for I'm sure that a check, like if you go to a restaurant and there's the table has one check usually, but then there's a bunch of items on the check, and so that would be like there's probably a check ID number, and then For the other ones, it's probably just like 1, 2, 3, 4, 5, 6. So that's kind of what this is here. This is doing a family. What is the primary key of the phone number table? It would be this. It's all of them. It's called an all key table. All right, so here's the concept of a foreign key. A foreign key is just a field. It's a field in a table. It's not a primary key in the table. It's probably not. I'm sure it's not even a candidate key. There's a reason for why it's not a candidate key, because if it's a candidate key, well, but it is a key of another table. So here we have an example here of we have this table of departments, and there's a manager, and each department has a single manager who happens to be an employee, has to be an employee, and in that, and so that can be the primary key, or this number can identify a primary key in the employee table, can identify an employee by the primary key in the employee table. So we see that engineering, the manager is Lisa, and sales and marketing's got one manager for both those departments, and that would be Maria. And technical support does not currently have a manager, in between managers. Manager just got fired because none of the computers worked anymore or something. I don't know. All right, so this is foreign keys are refer to the employee and department table. So data type of manager and ID. The data type of manager and the data type of manager and ID must be the same. Oh, yes, this and this, the data type must be the same. Yeah, I believe the answer is true. Okay, now in MySQL, there's sort of loosey-goosey, but it's like a varchar. It's only the varchar that it's got to be the same. The length of the char, the varchar, can be different in MySQL. In Microsoft SQL, that's not the case. In Microsoft SQL, it's got to be exactly the same all the way down to the length, the lengths that you give it. A big int and an int are two different fields, whereas in MySQL, they would be compatible regarding foreign keys. So anyway, null in the manager column refers to a row in the employee table with a null ID. No, there would not be. There would not be. First of all, there would not be an employee in the employee table with a null ID. So null in the manager column of the department simply means that we don't know who it is yet or hasn't been assigned yet. So I would say this is null, a false. Yes, okay. Values in a foreign key must be unique. I would say false. Sam Snead does not manage a department. He doesn't appear to. He doesn't appear to. Replacing null in manager column with 5384 assigns Sam Snead as a manager of that technical support department. I don't know if you want to do that. From what I know of Sam, he's kind of not okay, but yes, that would be. Null in the manager column may be replaced by 9876. No, because there is no 9876 over here. So that would be a false. All right, special cases. Yeah, I guess so. Yes, that happens too. Well, of course that happens. Okay, good. Okay, so you can look at those special cases. All right. Oh, here's another challenge. Let's see. Oh, okay. Let's just start. Okay, select where the code equals 858. 858 is a name of the country. It's Uruguay. Okay. And what's next? Select each candidate key for the above table. Okay. Well, certainly. Country. You'd think the name would be a candidate key. What else could be a candidate key? I think that the continent and continent population rank, those together could be those together could be a key, assuming that no two countries on a continent have exactly the same population. Assuming that, I'd say continent and continent population rank, that one. Name, if this is a candidate key, then academic theoretically this is also a candidate key, but it's a super key because it's got more stuff in there that needs to be and not candidate, not population. Okay, so let's see if that's the answer. Yes, it is the answer. All right, so great. Oh, referential integrity. Okay, it's 1253. And this has to do with you can't delete something that's gonna leave something else dangling. So here there's a foreign key here. There's a department and there's a foreign key here called manager, which points into an employee table, and it's a foreign key. And then someone comes along and wants to delete Lisa Ellison. So what happens? Because Lisa Ellison is a manager of engineering. What happens to this 2538? Okay, so if you go in there and fire Lisa Ellison, what happens to the 2358 over here? Well, 2538. Well, it can either go to null or, okay, three things. You can reject it. You can say, sorry, you can't do that. Okay. The second thing you can do is you can make this go to null. The third thing you can do is you can also delete this. You can delete the engineering. Okay, Lisa took the engineering department with her. That was the problem. So anyway, okay, so see, this is not lead. We can't have that. So because there's no employee over there. So that's what happened. The human resources department, the employee who was managing the human resources department just up and quit. And anyway, all right. So it's 1255. Referential integrity for composite keys, of course. You have to care about that. Referential integrity can be violated in 4 ways. The primary key is updated, the foreign key is updated, a row containing a primary key is deleted and a row containing a foreign key is deleted. So you have to say what happens in each case. Okay, so let's say, for example, Lisa Ellison's primary key changes for whatever crazy reason. You know, Lisa Ellison's primary key changes. Well, you can either not allow it, or you can change the primary, change this value over here. So let's say you change it to 2539, then this also changes to 2539. Okay, that's so those are the different possibilities of, and when you set up the foreign key, you specify what happens. Okay, you either cascade, or it goes to null, or you don't allow it. All right, one last challenge activity here. No, you don't have to install MySQL. Somebody just asked, no, you don't have to install MySQL. That's what your server is. Your server, you can start doing the SQL assignments, and your MySQL is already installed. You just have to learn how to log in. Okay, very good. I'll show you that next time. We're still doing the textbook here. I think assignments start coming like 2 more weeks or something, 3 more weeks if you look on this on the syllabus. All right, so real quick, with restrict referential integrity, let's start this up. With restrict, what happens if the code of the Netherlands is updated to XX? Okay, so let's say this code is updated to XX. What happens to 528 down here? Well, it either 528. No, it's not, because it's restricted. You can't. In other words, the update is rejected. It's restrict. And is that right? Ah, it is. Good. What's next? When set null referential integrity, what happens if the row containing Solomon Islands is deleted in the country table? Okay, so Solomon Islands gets deleted. 90 is gone. What happens to over here? This gets set to null. Row. Oh, set null. Oh, never mind. The row's deleted. That's what happens up here. What happens down here? The 90 is set to null. This is what happens. There we go. So up here, it'll get deleted, but what'll happen is down here, this will get set to null. Is that right? Yes, it's right. Okay, so anyway, it's 12:59. I don't want to go past the time. Very good. This, I guess we will continue this chapter next time. And I tell you what, next time I will, our assignments, 1 attempt. No, you can submit assignments as many times as you want, as many times as you need. You can modify if you don't get full credit. It can be like before the last week of the semester, or maybe the last week of the semester, and you look in there and you add up your score, and shoots, I didn't do all the participation in chapter 2. It's causing my grade to not get that A that I wanted. So then you just go back and do the participation in chapter 2, and at the end of finals week, when I do my grading, I'm going to go back and I'm going to collect all the scores from the very beginning, and so it will get counted eventually. Okay. All right. Are there any questions? But the assignment dates, no, assignment dates are not final. Assignment dates are you should get them done by then so you don't fall behind. And then also the the assignment date, I won't copy over the grades, or I won't do any grading before the assignment date, but I will after that. And it's possible that I do a round of grading and you haven't gotten yours done yet, so you end up with a 0. But that's just until you do it and I grade it again. Okay, so you know, and you don't want to fall behind, and people do fall behind in my class because I don't really enforce these deadlines. I kind of leave it up to you. So when people don't do well in my class, it's because they've put it off to the last minute, and then there's just not enough time at the end, and they don't get everything. And or what usually happens is they end up getting a lower grade than they could have easily gotten. So anyway, fantastic. I will see you next week, and be sure you fill out the schedule, that schedule thing, so I can choose some times that you all can attend if you want to. All right. Thanks for watching.